Hello class, today we're going to look at section 10.5, factoring x squared plus bx plus c. So our learning target today, we're going to be able to factor trinomials of the form x squared plus bx plus c. Here's what I want you to notice though. This only works when we have one x squared plus bx plus c. Okay? This only works if our coefficient in front of x squared is 1. As soon as that becomes a different number, we have to follow a different process, which we will cover later in the chapter. But for now, we are going to factor trinomials of the form 1x squared plus bx plus c. Now, in order to factor expressions of the form x squared plus bx plus c, we are basically going to do the opposite of the FOIL method. We are going to undo the FOIL method. We know from the FOIL method that when we multiply two binomials, we do x times x to give us x squared. Then we do outside and inside, which really ends up being p plus q times x. And then the last term is found by doing p times q. All right? So here's what this means. In order to factor a quadratic trinomial whose a value is 1, we need to find factors of the last number. So we need factors of 8 that add to 6. Okay, so we need two numbers that multiplied to equal 8, but add to equal 6. So, to do that, we could say we can use here x plus 4 and x plus 2, and that's because 4 plus 2 equals 6, and 4 times 2 equals 8. Don't worry, we'll cover it a little more in depth in just a moment. Let's get to some examples. So example 1, x squared plus 5x plus 6, all right? So we look at this, we notice that our a value is 1, our coefficient with the x squared is 1, so therefore we're going to be undoing the FOIL method. So what that means is we're going to be looking for factors of 6, okay, so two numbers that multiply to equal 6, that add to equal 5. All right, so to fill out the notes here, looking at this, the first term of each binomial factor is x, okay? For this trinomial, my b value is 5, and my c value is 6. All right? So here's what this means. We need to find two numbers whose product is 6 and whose sum is 5. Meaning I need factors of 6, so two numbers that multiply to equal 6, that add to equal 5. Well, let's list out our factors of 6. In order to get 6, I can do 1 times 6, or I can do 2 times 3. Those are my factors of 6. If I add together those factors, let's see what I get. 1 plus 6 would equal 7 here, and 2 plus 3 would equal 5. Well, we needed one whose sum is 5 here, which you should see with 2 and 3. So, the numbers we need are 2 and 3. So my factors would be x plus 2 and x plus 3. And again, the reason this works is because 2 times 3 equals 6, and 2 plus 3 equals 5. Now, you may be wondering to yourself, why does that matter? Well, let's FOIL these out. And that's another great thing about this whole factoring thing. After you factor, you can check your answer by simply multiplying your factors together, okay? If I FOIL out x plus 2 and x plus 3, I should end up with my original expression. So let's try it. FOIL method. First, we multiply x times x. That gives us x squared. Outside, x times 3 gives me 3x. Inside, 2 times x gives me 2x, and last, 2 times 3 equals 6. So hopefully you see why we need two numbers that add to 5, because that's going to make up this middle portion. Okay, so x squared, 3x plus 2x is 5x. So that's why the two numbers need to add to 5. But they also need to multiply to 6, because the last step in the FOIL method is 2 times 3 to give us our 6. So since this expression matches our original, we know we did it correctly. Let's do another. This next one's a little bit more difficult because as you can see we have x squared minus 8x, alright? So x squared minus 8x. So once we throw that negative in there, it does get a little more difficult, but we still use the same process. Let's look through this. So again, the first term of each binomial factor is x, okay? Since we have no coefficient in front of x squared, the first term of each binomial factor here is just going to be x, because x times x gives us x squared, all right? For this trinomial, my b value is -8, my c value is 15. Because c is positive, you need to find numbers p and q with the same sign. If they had different signs, meaning one was positive and one was negative, when we multiply those together, we'd get a negative number. But here we have a positive, so they have to have the same sign. Find numbers p and q whose sum is -8 and whose product is 15. So again, we are looking for factors of 15 that add to -8. Now, the numbers I can multiply together give me 15, okay? And again, we want them to both be negative because we have a negative in the middle. We could do -1 times -15. But if we added those two factors together, we'd end up with -16, which is not what we need. We need a sum of -8. So how about we try instead -5 and -3? Well, if you add those together, you get -8. So that works. So the numbers we need are -3. Sorry, let's put them in order. -5 and -3. The reason these work is because -5 times -3 gives me positive 15, and -5 plus -3 gives me -8. Factors of the last number that add to the middle number. So the numbers we need are -5 and -3, so we will have x minus 5 and x minus 3. You can go ahead and check your answer by foiling those two binomials. Let's keep going. Now in example 3, this one's a little different because, as you can see here, I have a negative number in the middle and a negative number at the end. But again, we still follow the same process. We still follow the same process, all right? The first term of each binomial factor is x again because we have a 1x squared. For this trinomial, my b value is -4. My c value is -5. Okay? Because that c value is negative, we will have to find numbers p and q with different signs. With different signs. All right? So again, our goal here is to find two numbers whose sum is -4 and whose product is -5. Okay? So factors of -5 that add to -4. Now, we only have two options for multiplying to get to -5. We can do -1 times 5. All right? -1 plus 5 would give us a positive 4. Which is close to what we need, but again, we need a negative. So maybe we should do 1 and -5. Because when we add those together, 1 plus -5 is -4. So there we go. The numbers we need are 1 and -5. So our factors, x plus 1 and x minus 5. And again, this one works because 1 times -5 gives me -5, and 1 plus -5 gives me -4. Factors of the last number that add to the middle number. Let's look at one more example of factoring, and then we gotta learn how to solve these. Although you're really just pulling from 10.4, but we'll get to that. All right, let's factor this one. Now, there's a couple more factors here, so this one's not quite as easy to find. But again, same process. Now in this case, my b value is 8, my c value is -20. Because c is negative, I know that the two numbers I'm going to use are going to have different signs. Different. Not much space there. All right, so our goal here is to find numbers P and Q whose sum is 8, okay, that add to 8, and whose product is negative 20. So that multiply to negative 20. All right, so to get to negative 20, okay, so we need numbers that multiply to negative 20. I could do 1 times negative 20, but when I add those together, I would get negative 19, not what we need. I could do negative 1 times 20, but negative 1 plus 20 is positive 19, again, not what I need. I could do 2 times negative 10, but when I multiply those together, I get negative 8, which is close to what we need, but not quite what we need. So maybe instead of doing positive 2 and negative 10, maybe we do negative 2 and positive 10. When added those together, you get 8. So the numbers we need are negative 2 and 10. Because negative 2 times 10 is negative 20, and negative 2 plus 10 is 8. So those are our factors. X minus 2 and x plus 10. Great. So now we need to solve. So let's say we have this equation. X squared plus 9x is equal to negative 14. Now, before we can solve by factoring, we always need our equation equal to 0. So here our equation, as you can see, is equal to negative 14. So to get rid of that negative 14, I'm going to add 14 to both sides, leaving me with x squared plus 9x plus 14 equals 0. And now we need to factor. So we have x squared plus 9x plus 14. Now what I need are numbers that multiply to equal 14, but add to equal 9. So let's list out our factors of 14. I could do 1 times 14, but that adds to equal 15. I could do negative 1 times negative 14, but that adds to equal negative 15, okay? Neither one of those options gives us 9. I could do 2 times 7, and hey, look at that. 2 plus 7 equals 9. So therefore, x squared plus 9x plus 14 factors to x plus 2 and x plus 7. And that works because 2 times 7 is 14, and 2 plus 7 is 9. And now we go back to thinking about 10.3. Nope, I'm sorry, 10.4. 10.4? Yeah, 10.4. Where we're solving quadratic equations that are factored. All we need to do is take each factor, so we take our x plus 2, set it equal to 0, and solve. Alright, to solve this, we subtract 2 from both sides, leaving me with x equals negative 2. Or we can have x plus 7. So we take our x plus 7, we set that equal to 0 and we solve. Subtract 7 from both sides, we end up with x equals negative 7. So my solutions are negative 2 and negative 7. So factor, then after you factor, set each factor equal to 0 and solve. Let's look at the checkpoint problems. Start out with the first 4. So we're looking to factor each trinomial here. Now, you should notice that the number in front of my x squared is 1, or there isn't a number, right? When there's just a 1, we just don't write it. So all we need to do here is find factors of 18 that add to 11. So let's list out factors of 18. To get to 18, I could do 1 times 18, but adding those together I get 19. That doesn't work. I could do negative 1 times negative 18, but adding those together I get negative 19. That doesn't work. I could do 2 times 9, and hey, if I add 2 plus 9, I get 11. So therefore, to factor, I get x plus 2 and x plus 9. And again, you can check your answer by FOILing it out. Number 2. Again, we just have 1x squared, so in this case, I need factors of 21 that add to negative 10. All right, to multiply to get 21, I can do 1 times 21, but that adds to 22. I can do negative 1 times negative 21, but that adds to negative 22. I could do 3 times 7, but that adds to positive 10, so we're very close. So we just need negative 3 and negative 7. Because negative 3 times negative 7 is positive 21, and negative 3 plus negative 7 is negative 10. So my factors in this case will be x minus 3 and x minus 7. Number 3. In this one, I need factors of negative 7 that add to negative 6. Well, to get to negative 7, I can do 1 times negative 7. And hey, would you look at that? 1 plus negative 7 is negative 6. So we already have our numbers we want. So we do x plus 1 and x minus 7. And last, for number 4, we need factors of negative 10 that add to positive 3. So to get to negative 10, I can do 1 times negative 10, but those add to equal negative 9. I can do negative 1 times 10, but those add to equal positive 9. I can do 2 times negative 5, but that adds to equal negative 3, which is close. Okay, so maybe we should do negative 2 times 5. Negative 2 times 5 is negative 10. Negative 2 plus 5 is 3, so these have to be my numbers. So x minus 2 and x plus 5. And last, we have one where we need to solve our equation. So first, we factor. So in this one, we'll do it in this pink color. We need factors of negative 21 that add to 4. So to get to negative 21, I can do 1 times negative 21, but that adds to negative 20. Negative 1 times 21, but that adds to positive 20. It's not divisible by 2. I could do 3 times negative 7, but that adds to negative 4. So, maybe negative 3 times positive 7. Those are the numbers we want because negative 3 times 7 is negative 21, and negative 3 plus 7 is 4. So this factors to x minus 3 and x plus 7. Now all we need to do is set each factor equal to 0 and solve. So we'll start with x minus 3. Set that equal to 0. We solve that by adding 3 to both sides, leaving me with x equals 3. That's one of my answers. And then we set our other factor equal to 0, x plus 7. We solve this one by subtracting 7 from both sides, leaving us with x equals negative 7. And that's how we solve. Factoring is one of the most important skills you will take away from this class. It takes practice. You need to do that practice. Get your homework done.